So this is section 1.1 in honors physics. So first we'll go through the equations. So this first equation we're going to do is for constant velocity, so only if there's no acceleration. So a equals 0. So this is just v equals delta x over t. So velocity or speed equals distance or displacement over time. All right, these next four equations, ouch. These next four equations are for when acceleration is not 0. And I'll talk about what these mean and what all the variables mean in a second here. But first one is delta x, or distance or displacement, equals 1/2 v sub o is initial velocity plus v sub f is final velocity times t is time. Next one is delta x equals initial velocity times time plus 1/2 acceleration, which is a, times time squared. Third one is vf equals vo, quiet counter, plus at. And then our last one is vf squared, so final velocity squared, equals vo squared plus 2a times delta x. So I'm going to pause the video while you guys get that written. So as Connor pointed out, these are deltas, not a's, so I tried to make them a little clearer. Alright, so now we're going to go through what all the variables mean. So v is just going to be our velocity. That's going to be measured in meters per second, abbreviated ms. And when I just use v, that means it's constant velocity. So if it's going to be acceleration, if the velocity is going to be changing, I'm going to use vo and vf. Delta x is displacement. And you can also use that as distance, and that's going to be measured in meters. T is time. I need to get that fixed, don't I? That's going to be measured in seconds. VO is initial velocity. And that's going to be measured in meters per second. VF is final velocity. And that's going to be measured in meters per second as well. And we've got A is acceleration. That's going to be measured in meters per second squared. One other thing I want to mention is each of these kinematic equations here has 4 variables in it. So you're going to need 3 variables, like of delta x, time, initial velocity, final velocity, acceleration. You need 3 of those to work with any of those equations. Does that make sense to everybody? So you see how these each have 4 variables in it. This one has delta x, VO, VF, and t. You need 3 of those variables to get to find another one. So if you have 3 of these things, you can find the other 2 with these equations. Does that make sense? Problem number 1. What is the average speed of a cheetah that runs 91 meters in 5 seconds? So what do we have in this problem? Nor? Distance and time. So our delta x is going to be 91 meters. Time is going to be 5 seconds. And we're looking for average velocity. We can just use that Vx equals delta x over t. So we're going to use, or V equals delta x over t. V equals delta x over t. So 91 meters divided by 5 seconds. And somebody want to do that in their calculator? 18.2 meters per second is the average velocity for that cheetah. Anybody have any questions over that one? We started out very difficult. Number 2. How much time does a car with an acceleration of 3 meters per second squared, I can't do superscripts on this, so it ends up looking like that, take to go from 3 meters per second to 12 meters per second? Alright, so what do we have on this one? What's the 3 meters per second squared? Acceleration. So a equals 3 meters per second squared. What's 3 meters per second? Initial velocity. So VO equals 3 meters per second. And what's 12? Final velocity is 12 meters per second. And what are we looking for? Time. So time is question mark. So what equation from those kinematic equations has acceleration, initial velocity, final velocity, and time? Third one. So we got VF equals VO plus AT. So VF is 12 meters per second equals VO is 3 meters per second plus acceleration is 3 meters per second squared times time. So we do that math. What do we get for time? 3 seconds. So that's our answer. So we're going to take 12 minus 3 gives us 9, divided by 3 gives us 3. Any questions on that one? So this one's a little trickier. A car accelerates from rest at a rate of 2.6 meters per second squared for 16.8 seconds. The car then slams on its brakes and decelerates at a rate of 5.6 meters per second squared until it comes to a stop. What is the total displacement of the car? So how many different parts of this problem do you think there are? 2. So there's going to be the acceleration part and then the deceleration part. We'll say part 1 is the acceleration part, and part 2 is the deceleration part. Alright, what do we know about part 1? So starts from rest. So what's our initial velocity? 0. Initial velocity is 0. And what's 2.6? Acceleration. So acceleration equals 2.6 meters per second squared. And what else do we know about part 1? 16.8 seconds is our time. And we're probably going to want to find our distance for part 1. So delta x1 is question mark. Alright, so what equation has those 4 variables in it? Yep, the second one. So it's going to be delta x equals VOT plus 1/2 AT squared. So we get delta x equals, that whole thing becomes 0 because initial velocity is 0, plus 1/2 times 2.6 times 16.8 squared. And then delta x equals, alright, so our delta x for part 1 is 367 meters. Alright, so now what do we know for part 2? Alright, and it's slowing down, so it's a positive or negative 5.6 for the acceleration. Negative. So it's slowing down to acceleration is negative 5.6 meters per second squared. Alright, what else do we know about part 2? Final velocity should be 0. We're going to be looking for the displacement for part 2. Do we know anything else? Not as of right now. Can we make any progress in part 2 with what we've got? We don't have like 3 pieces of information, do we? So we need to get another piece. What can we use from part 1 that might be helpful in part 2? How is the final velocity in part 1 going to be related to the part 2? Yep. So if we find the final velocity in part 1, that's the initial velocity for part 2. So what equation can we use to find the final velocity in part 1? Yep. And just a piece of advice when you're like finding two things, if you want to use information you've been given as opposed to information you found if at all possible. So we don't want to use our delta x just in case we get delta x wrong, then we get the final velocity wrong too. So we're going to say Vf equals Vo plus At. So Vf equals 0 plus 2.6 meters per second for acceleration times 16.8 seconds. And what's our final velocity for part 1? 43.68 meters per second. That's our final velocity for part 1, so that becomes our initial velocity for part 2. And now what equation can we use to find the delta x for part 2? Last one. So it's going to be Vf squared equals Vo squared plus 2a delta x. So we get 0 equals 43.68 squared plus 2 times negative 5.6 times delta x. I don't need that there. Right, so what do we get for delta x for part 2? $170 meters. So now to find the total delta x, our total displacement is going to be 367 plus 170 meters. So delta x total equals what? 537 meters. Any questions about that one? A stroller walks the first half of a straight 1.6 kilometer trail at a steady pace of 24 meters per second east. He walks the second half at a constant stride of 0.12 meters per second east. What is his average velocity along the trail? So how many parts of this do you think there are going to be? 2. What we cannot do is we can't just take the average of 2.4 and 0.12. What we're going to have to do is find we have the total distance as 1.6, and we're going to have to find the total time it took him to cover that, and then do total distance divided by total time to get the average velocity. Does that make sense? Because remember, even though he's going the same distance at each speed, what matters is how long it takes him at each speed. So what we're going to do for part 1, what's the distance he travels for part 1? The first half. Half of 1.6. 0.8. So delta x for part 1 is going to be 0.8 kilometers. Is that the unit we want it in? No, we probably want it in meters per second, so it matches the other one. So it's going to be 800 meters for delta x. And our velocity for part 1 is 2.4 meters per second. So you get our time, we say v equals delta x over t. So we get 2.4 meters per second equals 800 meters over time. So when we solve that for time, we get time equals 800 meters divided by 2.4 meters per second. And what does our time end up equaling? $333 seconds. Any questions on the part 1 there? Alright, now part 2. Delta x is the same, still 800 meters. Velocity for part 2 is 0.12 meters per second. So we do the same thing, v equals delta x over t, and we get t equals 800. Gosh, I just can't write. Let's start over. 800 divided by 0.12. To equal 6,666. We'll do 67 there. Alright, so now we want to find our total time. Let's use subscript t for that. It's going to equal 333 seconds plus 6,667 seconds. So what's our total time? 7,000 seconds. So now to find our average velocity for the whole thing, we do v equals delta x over t. What are we going to use for delta x for our total time, for our average velocity? 1.6 kilometers, but we want it in meters, so it's going to be 1,600 meters divided by our total time is 7,000 seconds. So what's our velocity in? 0.23 meters per second. So that's our answer. That makes sense because he spent a lot more time going 0.12 meters per second, so our average should be a lot closer to 0.12 meters per second. Any questions on that one or any other ones? Alright, why don't you guys